In part 2 of the exponent laws section, we're going to look at what happens when you have a power of a power. So, for instance, if you have 5 squared and you raise that to the power 3, cube it, what do you get? Well, cubing something just means take 3 of them, multiply them all together. So 5 squared, 5 squared, 5 squared. If we multiply all these, we can look at it a couple different ways. One way is just to expand 5 squared, which is 5 times 5, and 5 times 5, and 5 times 5. And we're multiplying all of these things together. And there are clearly 6 of them. And using exponential notation, we would write that as 5 to the power 6. Alternatively, we could have used the rule we just learned, which is we can add exponents when we have the same base. And so from here, we could have gone to 5 to the 2 plus 2 plus 2, which is 5 to the power 6. So either way we do it, we end up with 5 to the power 6. And can we make a general rule out of this? Where did we get the 6 from? Well, the first way we did it, we ended up with 6 of the bases, 6 5s. And we got 6 5s because we had 3 groups of 2, and those are just the product of the 2 exponents. In the second way we did it, we added the exponents 2 plus 2 plus 2. Again, there were 3 2s, so 3 times 2, which is 6. So the general rule we can make is if we have a base raised to a power m, that whole expression gets raised to the power n, then we can say that this is equal to the base raised to the power m times n. So as an example, if we have 2 cubed and we raise that to the power 3, we can just multiply the 2 exponents and write this as 2 to the power of 3 times 3, which is 2 to the power of 9. We can see that this is true. If we expand what's in the brackets there, 2 cubed is just 8. So this should be the same as 8 cubed. And 8 cubed is 8 times 8 times 8, which is 512. And if we write 512 as a power of 2, it's 2 to the power 9, exactly what we expected. Now, if we have a product or a quotient and raise that to a power or an exponent, what do we do with that? So if we have 5 times 7 to the power 3, again, we can just think of that as 3 of whatever's in the brackets multiplied by themselves. So we have 5 times 7 in the brackets, and we're repeating that a few times. Well, we can just rearrange everything in the brackets there and put the 5s all together, and then put the 7s all together. And we can clearly see that this is just 5 cubed times 7 cubed. So it's almost as if that exponent 3 gets distributed to both the 5 and the 7. And we can generalize this as if we have a product, a times b, and we raise that to an exponent. One way of dealing with it, it's not the only way, but one way of dealing with it, it would be to raise the power, the a to the exponent m, and also the b to the exponent m. Now, if we have a fraction, a quotient, like 3/4, we've seen this before, and we raise it to the power 3, well, what does that really mean? If you're cubing something, you just repeat the base 3 times. And you could go ahead and evaluate that, but what do we have on the top when we're multiplying the fractions? We're just multiplying the numerator times the numerator times the numerator, which is 3 times 3 times 3, or 3 cubed. And on the bottom, we have 4 cubed. And so once again, we can generalize this into a rule. If we have a fraction, a over b, and we raise that to an exponent m, we can just write this as a to the power m over b to the power m.